Hello and welcome to another tutorial. So this time we are going to be continuing with a few updates to the character controller. So it's already in a pretty good place. There's a lot of things I'm really happy with for it. A couple of things I want to be doing today is fixing up a couple of small minor little edge cases with some bugs there for it, and also adding in some head bobbing so that we've got that conveying a bit more of a sense of motion there that's happening as we're moving through the world. So let's dive on in. Now, in terms of sort of some of the changes that I want to make, so one of the things is if we go and take a look at the code, and this is something that I found from doing sort of further usage of this in another project, so using this in a project myself, is with jumping. So with jumping, at the moment, we have this flag for keeping track of if we are jumping. And if we take a look at how we use this, so looking at how it's being used, so things like footstep audio, stuff like that, won't play if we are in the middle of a jump. We have it that you can't trigger a jump if you're already jumping. So doing the particular checks there for it, and we can see jump gets set to true when we actually sort of start that jump, so when it starts applying the force. And then if we take a look, then it gets set to false at the peak, the apogee of the jump. So there's that period where we're falling where it won't be set to true. So that would impact on being able to double jump in that time. That's going to impact on a bunch of other things where it's going to think that at that stage we are not jumping. So that's something where that can cause a couple of little weird edge cases for what we're experiencing. So I want to actually change this around. And this is something where, because this is something that is quite deeply integrated, because a lot of things rely on that jumping flag. So my approach when I'm needing to make a change for something like this, something that's quite deeply ingrained, is I actually make this a breaking change. So first, I want to break it so that everything that refers to this variable is going to currently cause an error, and then I'm going to patch that up. So I want to treat the jumping as those two separate phases, so that rise phase and that fall phase. And then this flag will end up coming back, but I'm breaking it initially. So this approach of making a breaking change, so making the first part of whatever you're doing cause errors, is something I really recommend, in particular if the change sort of winds through a lot of different sections of code, there's a lot of things interacting with it. Just makes it easier to find all of them. Change the variable name, change the function name, whatever's required to make it that it breaks. So what I'm going to do in this case is I'm going to say, well, is in jumping fall phase, and we'll also have a is in jumping rise phase. Because what this is going to do is we can now see, it's just sort of highlighted on the side there, areas where this is now a problem, which is great. That's what we want. Because a bunch of these we actually won't change, because is jumping, we're going to end up changing the meaning of that so it corresponds to both that rise and that fall stage. But we just want to check for ones where it makes sense to shift it to actually being one or the other. So in this case, that makes sense for it to just still be is jumping, so we won't change it. But if we go then further down, so then we've got our check here for the grounded or coyote time. That one's correct. We won't change that yet. We've also got our other ones here where, okay, we're checking the is jumping here is being set to true. So this one we are starting to do a jump. So we're going to say is in jump rise phase is true, and is in jump fall phase is false. You could also use something like an enum for this too. That would be a viable option. So we could set the jump state to rising, falling, or inactive. That would also be applicable. Okay, we've set the variables there, so that's good. Now this one, we are checking if we're jumping, but if we look at how it gets used, this one is applying upwards forces and it's checking for ceilings. So this is going to be is in jumping rise phase. And then in this case, well, the jump is finished. So is in jump rise phase becomes false, and is in jump fall phase becomes true. So that's good. We can do a similar thing down here where we're setting this. So that changes. So that looks good. So let's check our other ones. So we've got here for updating crouch. That can be using both. That's very reasonable there, makes sense. The final thing that we likely want to change is because we've now got this tracking of rise and fall phase. So we do have setting of rise to false and fall to true. We don't have anything where we would set the fall phase to true. But that's okay, because that's something where when we are grounded, it would make sense to set it that we are no longer falling. So that's something where what I would do is, so we've got our is grounded check here. This, we're setting our jump count, things like that. So this would go to is in jumping fall phase is false. With that, if we take just another quick check, so that one makes sense for it being either rising or falling. That makes sense for being rising or falling. And that one also makes sense because they're all related to sort of the movement that should only be happening on the ground. So that's good. And with those, what we then can do is public bool is jumping, and that becomes is in jumping rise phase or is in jumping fall phase. So we introduce a breaking change, makes it easy to find the stuff. We fix those things, and then we bring this back for fixing the remaining errors. So this should mean our jumping is a little bit more reliable. It means now on the falling edge, we'll be able to jump. So double jumping should be a little bit easier. It should mean that we can see that's an interesting thing, and that's another one we want to also fix. When we're running like this, if I jump, it kicks us out of the running. So that's another change there. Now it's generally working okay with that running, and if we do another little bit of a check, because we've got the running is set to a toggle, and so we want to make it that jumping doesn't actually take us out of the sprinting, because that's something where it doesn't really feel good having that sort of kicking us out of it. So what we want to do is when we go and actually change the running, when we jump, we're not going to turn off running anymore. So we saw the FOV kick is happening and that's working correctly, but if we try and jump during that, that was actually messing that up. So we want to fix that because we should be able to jump while sprinting, and we want that to hold our exact same speed. So we don't want anything messing with that. So what we want to do is take a look at what happens when we sprinting and when we're jumping, and make sure that those aren't interfering with each other. So if we look, running, we are using that for controlling our max speed. We are updating that. So we've got our general logic there for that is looking pretty good. So the setup here, we can see update running. It's going to set running to false if we are not grounded or in coyote time. But that's something where that's fine, except that we want to make it that it can only do that if we are not jumping. Because if we're falling, things like that, yep, that makes sense that we can't run. But if we are doing a jump, we should still be able to run. So this is where we can say, and we are not jumping. What this should mean is now I can, as I'm sprinting, I can jump in the middle of that and I won't lose any speed there. I still have that sprinting speed. We don't get any FOV kick changes then. So I'm sprinting and I can jump. Now, that seems to generally be working. We don't get the FOV changing, which is good. It does definitely sort of slow down a little bit, and that is likely going to be a case of, well, because we're in the air, our velocity is not going to carry over to the same extent. So we do incur a little bit of a slowdown, but that's something where you could balance and adjust that. That's something that we've got already the controls there in terms of the in-air speed and everything, because that's going to be tying into our speeds here in terms of, okay, well, if we're grounded or in coyote time, then it's using these. What I could also do is change this to is jumping. So if we're grounded, coyote time, or we are jumping, that way then it won't use the air control speeds, it just uses our normal ground ones. So what I should find is that it maintains velocity much better. So I'm running, and I jump, and it feels exactly the same. So that's good. So we've improved the behavior there with jumping, so that's great. So I said I wanted to add in head bob, and that's something where I want to add this in. Now, it's something where you want to make sure you've got a range of controls for it. You want to make sure you've got the ability to turn it off as well. So we're going to set it up so we can do that. Now, I'm going to set these settings up here near the camera. And one of the first things I am going to do is it will have a head bob enable, which I will set to true by default. Now, how are we going to do this head bobbing? So we need to move the camera. Now, the camera is already a separate object, so we're changing its local position. Now, what we can do is use essentially a sine wave that's going to go up and down. And as we move, we can then update that. We can also, we'll do a little bit of experiment with seeing how it works if we put in a little bit of movement to the side. So roll is something that we could add in, but from testing that I've done, roll really can be not good. We'll have a little bit of a look and we'll see how that goes. But we probably won't end up using any roll changes in there. But initially we'll just have some translation changes. We also want that to be able to vary with speed. So as we're going faster, we want that to be more pronounced. So what I'm going to do is I'm going to have a couple of things. First thing I want to have is head bob, min speed to bob. Because if we're below a certain speed, we don't probably want any head bobbing. We want to keep it fairly steady. We want to then also have, I'm going to set up an animation curve. This is going to be head bob. So we want to have one that's controlling the vertical translation versus speed. So I like animation curves for this because it makes it really easy to balance sort of the transitions there for it. So I'm going to say V translation, so vertical translation versus speed. So that's going to give us 1. Now speed is going to be relative to the maximum speed. So I'm going to actually call that speed factor. So that'll be for the vertical translation. So we want, primarily it'll be vertical, but we also want to have a little bit of horizontal. So I'm going to chuck in an animation curve, head bob, H, translation versus speed factor. So that's good. That's going to be controlling that. Well, the other thing that's also going to change potentially is the interval. If we're walking slowly, it's going to be a much slower transition there than if we're moving really rapidly. So let's have something where we can control that as well. So animation curve, head bob, period versus speed factor. That way we can make it faster when we're going faster and slower when we're going slower. So that's good. That gives us the range of options that we need for this. And we can then get those configured. So that's going to be the first thing I do, is getting these set up. So if I go to my configuration, so we've got head bob enabled here. So vertical translation versus speed. So going to start with reliable S-curve. So this would mean at 0% of our speed, 0% movement. This would mean at full speed, we have 1 meter movement, which is probably a little too large. So I'm going to reduce this. So I'm going to edit this key, and I'm going to say, because this is both up and down. So this is how much it would be if we're going at just full sprint. So I think in that case, if we're going at a really full sprint, we're going to say 0.2. It might be a little too large, but we can always reduce that later. So that's the vertical translation. Now horizontal should be a lot less. Because if we think about it, when we're running, we're going to tend to be fairly straight sort of line. So I'm going to reduce this to something more like 0.05, which might be a little too low. We can always boost that up if we find we want more. And then the period. So period, we'll start with an S-curve, but it's actually going to sort of flip around. Because when we're moving quite slowly, we still want it to be a non-zero value. So we don't want any zero values for this. So we're going to say the period is half a second when we're moving slowly. And then as we're moving faster, we're going to drop that to like 0.25. We might find we need to drop that even more, but we'll start with that. And we'll get a sense of how this is looking. The idea is going to be the faster we move, the more we bob, and the faster we bob. So it should help convey that feeling of speed for it. So what we can then do is, if we go back to our code, well, we need to have a way of keeping track of the progress we're at through the head bob. So I'm going to have a protected float head bob progress, because we're essentially going to use a sine curve and we're going to sweep through a full sine curve and then keep looping through that for creating our bobbing effect. So then I want to go to where I've got the camera. So that's late update. We update the camera. So this makes sense just to go in that because it's part of the camera logic. So here we're doing all of our positioning, changing the rotations, tilting the camera, stuff like that. So what I'm going to do is here. In between is when I'm going to do the head bobbing. So what I'm going to need to check first is config if head bob is enabled. And we don't want to be doing head bobbing unless we're grounded. And we're grounded. So head bob enabled and on the ground. Otherwise, makes no sense for us to be doing anything. So what we need to do first is we need to work out our speed factor. So our speed factor is going to be based upon our current speed, and it's going to be based upon what our maximum speed is that we might be. So to get our current speed is our linked rigid body, velocity, magnitude. Well, we might be below the threshold to actually bob. So I want to check if current speed is greater than or equal to config head minimum speed. Moving fast enough to bob. So that's good. So we need to, as our starting point, because we're going to take our camera and offset it, that means we need to know what our default camera position should be. And that's okay. We actually have already got stuff where we're calculating that. Because if we take a look for linked camera transform dot position, we don't have anything for that, but local position we do, because we actually have stuff where we are calculating it. So what I'm going to do is use this, because this is going to reliably give us our default position. So we're going to have vector3 default camera offset, and we're going to set it to that. So we've got our camera offset calculated, so that's great. Now we can then start to, when we know now that we should be bobbing, so because this is a case of, okay, if we're above that threshold for actually bobbing, that's great. Well, first thing we want to do is update our progress. So we're going to say head bob progress plus equals. We need to know the period. We need to know how much time has passed. So we're going to do a config period versus speed factor. That means we need our speed factor. So that's okay, because our speed factor is our current speed divided by, and this is going to be down to whatever our maximum speed is. So we don't have with that, the easiest thing we've got is we actually already have this current max speed. So we just take a quick peek at that. That's already checking stuff like crouch, everything like of that. So it's just going to work with all of our current things. So that gives us a speed factor. That'll be between 0 and 1. So we can evaluate this. So if we then do time dot delta time divided by that, that's updating our progress. So our progress is going to go from 0 and we want it to go up to 1, and then when it hits 1, we want it to loop back around. So easiest way for me to do that is I can say, well, head bob progress percent equals 1. So we modulus it. So update progress. Now I can actually work out our vertical and horizontal translations, because we've got config and we take our head bob and we use the vertical translation. Again, we chuck in the speed factor. So this is going to be max V translation. Then we'll have, so that we need to evaluate, we'll have almost identical a max H translation. So that's going to be config, head bob, and it'll be our H translation. Again, evaluate with speed factor. So we're determining the maximum translations. It's not the translation we're applying, it's the maximum translation, because then we use sine to work that out. So what we would do is a mathf sine. We use our head bob progress, which goes from 0 to 1, so we can multiply that by mathf pi times by 2, because a full cycle of the sine wave, so an up, back to 0, down, and then back up to 0, is 2 pi. So 2 pi radians or 360 degrees. So this will always cycle. So this we can store as sine progress. So that works. And then we can update, so default camera offset plus equals. So we'd have vector3 dot up times by sine progress by max v translation. So that's adding in the vertical component. Then we would have default camera offset. And then we have vector3 dot right. Again, sine progress by max horizontal translation. So update the camera location. So that's good. Now, if we're not above the required threshold, then what we're going to do is say head bob progress is 0, so we reset it back. So, okay, good so far. We could also decouple these, so the horizontal translation is running at a different interval to the vertical one. We could shift it slightly out of phase. That's something we could do. Likely people wouldn't notice, but it's something that if we wanted to, we could potentially do that. So then I can just update the offset here. So I can say linked camera transform local position is default camera offset. Now the reason I grabbed the offset here and am setting it like this, so it's setting it in cases where it otherwise wouldn't, that's because if we've been running, we might be at the peak of a bob and then stopped. We want to bring it back down to 0. So this will just ensure that. Now we could do a bit of a lerp on this. So this is something where we could absolutely do a bit of blending. So what I might also do is just, we've got control for it. So public float head bob translation blend speed, which you might set to 1. And then here, this I will actually do a vector3 move towards. So we take our linked camera transform local position. We're moving it towards the default camera offset, and we're moving it config head bob and translation blend speed by time.delta time. So that will just blend it towards it. That means we can control the rate if we need to. We can make it that it's a bit of a smoother transition there, which is going to work a little bit better. So that should largely do it. So we can test that out. We might need to adjust the thresholds, and that's okay. We just want to get a sense of efforts sort of working about the right level that we're after. So we're walking. You can see we do a bit of movement there, which is good. Now we don't really notice it when we're running. It's a little bit there. So what we could do is we could adjust a couple of things. So vertical translation, I could increase the high point there for that. So I could bring that up to maybe 0.25. And what I could also do is the horizontal translation, increase that maybe to 0.1. And I think we adjust the period a little bit as well. So this is something where I think we slow it down a little bit at the lower speeds, and we'll actually then speed it up at the higher speeds a little bit more. So just a little bit of tweaking, adjusting the values either way. So that's still pretty rapid. So I think I'm going to change this to 1. Now that should be a little bit better. So that's going to give it a bit more speed there. But one of the things we'll be running into is, so we used the current max speed. If we take a look at this, that updates. So that means that 1 is achievable when we're walking. So speed factor of 1 is achievable both when we're walking or running. So actually what we want to change this to is if config can run, then we use config run speed, otherwise config walk speed. So what was happening there is when we were walking, well, our max speed when we're walking is going to be the same speed we're going at, because that one's giving you your current max speed based upon all of the possible configurations. So it's not going to look at what is your overall potential max speed when you're walking. It's just what is your max speed in the current movement mode. Whereas we need to be looking at, no, what is the absolute max speed? So this should mean when we're walking, it's a lot slower. It's moving much, much better. When we're running, it's much more obvious. We've got better separation there. It's splitting up and indicating things a lot nicer. So that's looking pretty good. Let's do a couple more bits of testing here. So one of the things we want to do is with going up the stairs. We notice with going up the stairs, we do end up moving, like jumping ahead quite a bit with the stairs. So something that I'm going to do with the stairs is reduce our look ahead range here, because we do currently, it factors in the radius as well. So I'm going to actually drop that to half. It's not going to make a huge impact, but it'll mean we don't tend to sort of teleport ahead as much on the stairs. It should mean that our movement feels a little bit better, which it does. That's a bit slower than movement there going up, which is great. So that's looking pretty good. And we do get a bit more of a bounce going down the stairs. That's where we could sort of, again, tweak our settings there at the lower speeds a little bit if we wanted. But we've now got improvements there with the running. And, I can be running. And so the jumping is working nicely. If I'm crouched, I still get a little bit of head bob, but it's much less. And I can still sprint when I'm crouching, and again, a bit more head bob, but a lot less. So we've got the running, the jumping working a lot better there. We can be jumping while we're running, and we don't lose the field of view changes. That feels a lot better, and we maintain our speed, which is great. We've got head bobbing, we can turn off and on. You do want to make it easy to be able to turn it off, because that's something where those extra bits of motion can really make some people motion sick, so always good to have options for being able to turn it off. As I said, we could chuck in a bit of rotation there, but every experiment I've done with adding in even just like, I'm talking 1 to 2 degrees of rotation, it feels odd. And I think the reason it feels odd is we naturally, our view kind of auto levels as we're moving around the world. So it doesn't feel right. It feels sort of artificial. And that was something that was a bit surprising for me, that even 1 to 2 degrees just felt weird and wrong. So you could add in rotation, but it'd be a little bit wary of doing that, just because it doesn't, so far I haven't seen it feel particularly good setup wise. But we've got it controllable. We can adjust it with different speeds, different thresholds that we could put in there. Something that also you could have effects that adjust that at gameplay, at sort of runtime there. So it could be something that just massively increases that if you want to make the player feel a little bit more disoriented, or if you wanted them to feel like they were running just sort of super fast, you could be really messing with that quite a bit. But that gives us a bunch of updates and improvements there for it. Makes it feel a little bit better in terms of the movement. So dive on in and experiment with it. See about other changes you might want to make to things like the head bob, any adjustments there you might want to play around with, just to sort of get the feel that you're after for your particular game. Thanks folks, I hope you found the video interesting and helpful. If you have, chuck in a like and subscribe, really helps out, really appreciate it. If you've got any questions, chuck in a comment below. If you're looking for the code for the project, the link to that's in the description. The code's available up on GitHub. I've set it up so that there is a tag for each one of the videos so that you can easily just go directly to the particular code for this. You can use that code in any of your own projects, whether those are commercial or non-commercial ones. You're freely able to be using it there. And if you've got sort of other things you'd like to sort of see added into the character controller, chuck in a comment below. Always keen to be finding other cool little things that can be adding to it. There's lots of extra bits I want to be adding to it, but if you've got any ideas that you want to particularly see, just chuck in a suggestion below. And if you're looking for other ways to support the channel, I do have a Patreon, and there is a link to that in the description below as well. But until next time, bye.